Alright YouTube, this is gonna be a video on how to create just a simple Windows program to just have a simple window pop up right now. Eventually these tutorials are gonna get more involved and more deeper into actually getting some graphics and game development going. But first we're gonna start with the simplest basic starting block, and that's just a simple window that we want. So we're gonna begin with opening Visual Studio 2012. I'm using 2012. 2010 will work. 2005 will work. Most of these that should be backwards compatible. So we're gonna start with a new project. We can call it whatever we want. This is eventually gonna build into an engine, so I'm gonna call it just engine tutorials, and it'll be sort of a sandbox kind of idea. I'm gonna throw it on my desktop. I'm gonna create a directory. Alright, so hit OK and hit next. And we want an empty project for right now because um, we don't need any fancy stuff yet. Eventually, if we want some preprocessor directives and stuff, we can set that up on our own. So hit finish after you select. Make sure you select empty project. So now we have our solution explorer. We have nothing in there, so let's add to our source files. We want to add a new item. We're going to add a C++, and this is going to be WinMain. You'll see why we're calling it WinMain. This is essentially the main. This is I guess the equivalent of main, and it'd be the equivalent of the main void. This is essentially the same, but it's for the Windows version of it. So we're gonna call it WinMain. Um, so now we have an empty project. We have empty C. So we're gonna start coding this. So like every program, we need a place to start. We need a place to tell the compiler, hey, this is the beginning of our program. So we're gonna in Windows programming, it's actually just WinMain. So we're gonna use int callback WinMain, and we're gonna have in h instance. Gonna have another in parameter. It's gonna be another h instance. This is gonna be h previous instance. In gonna have a long pointer to a string, the command line, lp command line, and another input int ncmd show. Well, you can see we're having some issues here. We're gonna get this arrow, this little issue here. That's because it doesn't know what WinMain is. We gotta include it. So we're gonna include windows.h, and that should take care of that error. And there you go. However, Windows H is a really huge header file, and we don't need everything that's going to be in there. So to use the slimmed down version of Windows, we're going to use a pound define called lean and mean win32, I believe. No, win32 goes in the front. We're going to define this win32 lean and mean. Win32 lean and mean. These parameters, this is essentially copied and pasted from the MSDN's website. Let me see if I can pull up the WinMain. Apparently I don't have it up, but if you go on the MSDN website, this is essentially copied and paste. Actually, let's hit F1. F1 will give us what we need. No, that didn't bring up the right version. Yeah, this is what F1 gave me. But this is for Visual Studio 2013. We want it for 2012. Yep, that's still not right. Here, WinMain section. Here we go. See, this is essentially the same exact, uh, it's copied. So let's go through the parameters. The H instance is a handle to the current instance. So this is what's currently running. The previous instance is just making sure that there's only one instance of this program running at any time. The LP command line, this is for if you have any command line inputs for the program. That's what this LP string is for. And this int controls how the window is to be shown. This parameter can be one of the following values. And all these parameters are actually just given by Windows, or your operating system will give you all these parameters. You don't actually. This isn't anything you'll actually have to worry about. All right, so we got the WinMain. The first thing we're gonna do once we get into the WinMain is we need to actually fill out something called a Win class EX. Hit F1. Alright, so the Win class structure is similar to the Win class. There are two differences. Alright, that didn't give us too much. So it's saying it's similar to this. So let's go here. Alright. It's just it's gonna define a lot of basic properties for the window that you're gonna have. You're gonna have a style member, the WinProc. I'll go into the WinProc a little more and deeper later when we actually hit that area of this tutorial. This is the number of extra bytes to allocate for padding issues, I'm assuming. Win extra, H instance. Most of these are going to be null, except for a few of them, and I'll explain it when we start coding. I generally like to create separate functions to do this, otherwise you're going to end up cluttering WinMain a lot, and it'll be very non-intuitive and hard to follow. So let's create a couple of functions for this. We're going to do a generate window. I'm gonna do pragma region. These are what are my function prototypes. Found pragma end region. So we're gonna have something called generate window, and it's gonna take in a win class ex by reference, and that's it. However, we need a return type. I generally like to return a bool. That way I can, if I ever need to verify that this actually, something went wrong, I can return a bool value and handle it properly. So let's fill out this generate window. Got a bool, generate window, win class ex, and WCX. Alright, so let's zero out the memory. WCX, zero it out. Size of win class EX. Alright, so this is gonna actually just null everything in that structure, in this win class structure. Why doesn't you like this? Oh, this runs an address of. There we go. Yeah, I'll take a pointer. It takes actually a void pointer. The destination, like this destination is it's obviously a pointer. This isn't a pointer, so we need to get the address of that to zero out. So it's going to zero out everything that's in this location in memory. So what are some of the parameters that we got to fill out? So let's just go by. Okay, let's go by just down the list. CBL extra. Like I said, most of the stuff is gonna be null. and this one's gonna be null. This is gonna be just zeroed out. Let's go to the next one. CB size. No, dot CB size, and this is gonna be the size of a Win class EX. Alright, and we're checking on an extra. Is there anything extra that we need? Nope, this is gonna be null too. HBR background, this is gonna be the basic main background, and null. It's gonna zero it out, which is essentially gonna be black. WCX. The cursor, we don't have any custom cursors, but I guess we could use something in Windows. I'm gonna do load cursor, no, IDC arrow. This is actually gonna go and use the default cursor that's used by your operating system. So depending on your operating system, this will change what kind of cursor is used within the Windows, within that application. Obviously, if you lose focus out of that, it's going to use whatever the other application cursors are. WCX. What else do we have? H icon. We don't have an icon, so we're going to just null that. You can create custom icons, and maybe a couple tutorials down we'll talk about icons and how to create them, but that's for another day. If we don't have a regular icon, we don't have a small icon. Alright, the instance. Now this instance is the instance of the program that we're going to be using, and this is going to be given by Windows. However, we don't have access to it. It's up here, and it's being passed into WinMain, so we don't have access to it. So what is our solution? What can we do to fix that? Well, we could pass in a second parameter here and catch this H instance when we generate it and have it as a parameter. But to make things easier, and this H instance is gonna give you a lot of the benefits that you will need, that you could potentially need for other things, such as like cursor position and keyboard input. So what we're gonna do is I'm gonna make a global. Yeah, I know all you object oriented will be saying boo, no, don't make globals, but in this case it makes sense to make it a global. It's going to be faster access to it, and it'll eliminate a lot of function calls. I mean, if I have a get H instance and I'm constantly calling that get H instance, it's gonna cause a lot of overhead. So we don't want that overhead. So I'm gonna create a primary region for global variables, global vars, pragma end region. And this is going to be an H instance, and you can call it whatever you want. I'm going to call it DH instance just because my name begins with a D and I like using my name. Obviously this isn't set to anything yet, so we have this DH instance. So now when we get into WinMain, we can set this DH instance to this H instance. And now we can set this to the DH instance. And there we go, we got access to it. Alright, well, what else do we have to fill out? H instance. No, we just did H instance. So let's see what else we have. The win proc. Alright. Win proc. It's complaining because there's no. This is actually taking in a function pointer, and we're gonna be pointing to a window proc function. see if this will give us any insight on what window proc is. 12. That doesn't give us much, so alright, so we'll write it. So we're gonna need to create a window proc. Let's see. Go here. Search Windows proc. Nope. Alright, none of this is giving us anything we want. So I'll wing it. The WinProc essentially is a way for your operating system to handle messages. It's a way for your program to send and receive messages from your operating system. There are various messages that it'll handle, such as resizing of your window, clicking around, generating the program itself. All this stuff is actually going to be, somewhere has to be created, and this is all going to be done through your operating system. But how's your program going to be able to handle it? You got to have something. So that's what this WinProc is. It's your way of interfacing with whatever the operating system is sending messages to and from you, from your program. So the syntax can be a little daunting at first, but you'll calm down once you realize it. So we're gonna return an L result. The L result is gonna be what is the result of the window processing a certain message sent by your program. Callback. I don't really know what the purpose of the callback is. Maybe someone who wants to comment can comment on it. I just use it because that's what MSDN's function stubs use. So that's what I use. And you can call it whatever you want, but it needs to match this because this is a function pointer. So I'm gonna call it the same thing, WinProc. Now the WinProc is gonna also have 4 parameters into it. It's gonna have an in parameter of hwind. The hwind is essentially your window. That's simple. It's a handle to your window that the program is running on. It's gonna take in a uint, a umessage. This message is what's being sent to the operating system. Then you have an in. You have a wide param, and you have an L param. Wide W param. Alright, so getting a lot of syntax errors here. There we go. Let's see if I hit F1 if this will give me anything. No, it won't. It doesn't want to play 9. Let's just search it. WinProc. There we go. Alright, so here's the window proc. As you can see, I copy and paste it. There's no need to not to. H1 is the handle. The W param and L param. Additional message information. Like it says, it just depends on what the operating system's gonna do. But a lot of the W param and the L param, I'll get into more of those when we get into actually handling messages. For now, just recognize they're there. So now you see this error is gone because now there's an actual WinProc and it's being able to find that address. All right. Let's finish this up. Got the WinProc, the class name. Now the class name is can name it whatever you want, but it needs to match eventually what your H-wind is gonna be connected to. Um, and I'll explain more when we actually go into creating the H-wind. So for right now, um, we're gonna create a text, and this text is gonna make it ask your Unicode, so we're just gonna leave it like that. And we'll know what class, we'll just call this WinMain tutorial. Alright. Actually, eventually this is not going to just be the tutorial, this is going to be our main engine. So main engine, main engine window, there we go, main engine window. And I believe there's one last parameter we got, and that's two more, menu name and style. The menu name, we don't have a menu, so we're going to null that out. And the final is the style. The style is going to be what defines what you can and cannot do with this window. We want to be able to redraw in the vertical. Yes, vertical redraw. Ord with a horizontal redraw. We want to be able to redraw both horizontally and vertically. Enable double clicking. And on DC. So we got the vertical draw, the redraw, the double click, and your not really sure what that's for. I just put it there. Alright, so we've talked enough about that. So alright, so we've populated this WCX WCX. So we gotta register this class now. So in order to make sure, like, ensure this isn't what's breaking. This is for debugging purposes, and it'll help down the road. So pound, how do we do this? Pound if debug. Sorry, I've already created this, so I'm going back and forth to make sure I don't forget anything to do anything. D3D engine. Yeah, pound if underscore debug. Pound if underscore debug. This is all because, you know, this is, we just want to do this code if we're in debug. If we're in release, the compiler needs to not worry about this, because otherwise it's gonna just cause more overhead. So now, pound if register window ex, would register window, no, class, register class ex, and we're gonna pass in the address of this win class. So many typos. Alright. Okay. So if it succeeds, we just want to say, hey, we succeeded. We don't want to do anything, and it's done. Alright. There's nothing else we need to do. We'll just return out of this function. Return. Now, otherwise, now you may choose how you want to handle this. But you can either do an assert, a C style assert. Of course, that would require us to do a pound include IO stream. Pound include is an assert. There we go. And that'll allow us to do this assert. And that's just gonna give us the message box. We could do message box A and have a message box there. But I find these to be a little obtrusive and really annoying to deal with, because you gotta constantly just like, oh, something broke, okay, something broke, okay. Instead of doing that, we're gonna need the IO stream. Let's attach a console to our program, so that way we can just kind of have these error messages in the background of our program. So we're gonna create a console and attach it to this program, to our code. We can that way later on in the program we can always you just use our standard console output to output any debug information or even file loading. We can keep track of what's being loaded in files. All right. So for this we will need uh, we're gonna need Windows X. Well, let's first just so we're gonna need another global because we want to be able to access it anywhere H console. All right. So like I said, I like to, you know, I could do all of it in main, but I don't. So we're not gonna do it all in main. We're gonna create a separate function that'll be in charge of generating this console and attaching it. So we're just gonna call it generate console. Okay, we got a console. So now we gotta actually write this function. So let's go down all the way at the bottom. Bool generate console. Takes no parameters, takes nothing. It doesn't need anything. So we're gonna do. This is essentially a copy and paste again from the MSDN, but I'll write it out so you can follow along. Handle out equals get std handle std output handle. This will give us the handle to the actual standard output handle. So this is essentially what you're doing when you have stdio. H console. We're gonna set our console to that. Open OSF handle long handle out underscore O underscore text. Like I said, I'm just copying this. What is it complaining? Okay. So now we got these errors. It's like, hey, we can't define them, so let's figure out what we're missing. I'm pretty sure it's in Windows X. See, there you go. Windows X. Where are all these errors from? Do I need both? Shouldn't need both. Windows 31. What is that? 132. Huh. I think I need both. Pound include Windows. Pound include Windows.h and Windows X. There we go. No, that didn't do it. So it's not the Windows X. Hold on, let me figure this out. There we go. We need a pound include io.h, pound include fcntl, the font controller. I guess that's what that is. There we go. Nice and clean. Alright, let's continue. You know what? I'm just going to copy and paste this and not waste any more time. And we'll just look at it. You can just copy and paste this. No, that's not it. That's not my phone number. There we go. Alright. So, yeah, I don't really want to go into much of this. If you want to research it, research it. It's not really crucial to programming Windows, but there it is. This is now we have a console. We have this in and output console. Um, and they're both being used as the STD handles, STD input. All right, so now we can just output to it, just like any other input output you would do in a console application. Uh, so printf, and we have error, because this is if the window class generation was not successful. That'll tell us that it is in this function that we are failing in. Or we have Visual Studios. Or we have Windows class generation success was successful. Alright, so that has created a window, but we never called it, so it's not going to do anything for us. It's just going to sit there and be happy and not do anything. We need to actually call this function and actually do something with it. So if the generate window, wait, we have a problem. We want to return a bool from here, not just a regular. This is return true, return false. Alright, so if the window does not generate correctly, then we want to just break out of this, break out of main, and make sure just kill the program, because no point in moving on if we don't have a successful class generated. Alright, so let's run this program and see what it does. Let's add a system pause. System pause. This is just to make sure we can see what's going on. Alright, so run the program, see what it does. Yes, build it. 3 errors. Linker WinProc. Oh, never actually gave this a body. Let's just comment it out right now. Actually, no, we need it. Awesome. Let's just give it a body. Now's a good time as any. So the WinProc, might as well talk about it. It's gone. It's gonna be a work in progress as we do more things. It's gonna do different things. So we're just gonna do a return def window proc. We're gonna return the hwin, a message, wparam, and the lparam. Let's see what this does. Okay, it's letting me undo it. There we go. Let's see what this does. Alright, the WinProc function. This will call default window procedure to provide default processing for any window messages that an application does not process. That is telling us that for any messages that we get that we aren't handling manually, it'll do the default. And since we're not doing anything, this will always return the default value when you call this function. So let's see, what else do we have? It looks like just linker errors. So let's try running it again. Alright, this didn't print anything. Class. Why didn't you print anything? Did we miss a step? let's see, what did we miss? Ah, oh ho ho. We never actually called this function, so it didn't do anything. Let's actually call it. Actually, before you generate the console, you want to allocate a console. Console. There. This will allocate a console for this program, and this will give us access to it. Now let's run it. There we go. Success. Windows class generation was successful. Alright. So that means this worked out good. \n. Alright. So we got a Windows class generated. Yay. One step out of the way. The next step we need to do is actually create a window. We have a Windows class, but we don't have a window, so we need to create a window. This creates the handle to a window. Just like the Windows class, I want to do a generate window function, but obviously it's not going to be a generate window. We're going to do a generate hwind, a handle to the window, and it's going to take in an hwind reference. And alright, we'll leave it at that for right now. So we come down here, we're done with this function, so we can collapse that. This we're good with, and this we're good with. Clean some of that stuff up. So below the generate window, we're going to do a generate hwind. We're going to zero it out. It's always a good idea to zero any default classes out. You never know what kind of garbage will be, especially if you have memory pointers in the actual and the structures or the classes that you're using. You don't know what it's pointing to. It could be memory you have no access to, so you just want to just clear it out. Size of wind. Alright, so we gotta start filling this class out. Actually, we don't need to zero this out, because, wow, what am I talking about? The hwind isn't a class. It's a handle. This means it's a pointer. So, we're not going to do anything with it. We're going to... How to go about explaining this. Alright. To create a window, we're going to eventually call this create window ex. Alright, it takes the D word ex style. Well, let's F1 it. This will give us a little more insight on what we're doing. Alright, so it wants an extended window style for a list of possible. So the style of the window. The style of the window, meaning, are we going to have a minimize button, maximize button? Are we going to be able to resize it? Are we going to be able to... What are we going to be actually able to do with this, with this actual window that we're creating? So there are two. Well, we'll deal with the more specialized cases when we get to it and evolve its function as needed. So the most basic is this overlapped window. This is just gonna make sure that the windows it overlaps the windows in a cascading style. Overlapped. The window is an overlapped window. it has a window edge and client edge. It's just gonna like see how Chrome is overlapping the Visual Studio. That's how the window is going to be running. Alright, so then it wants a class name. Now this class name, as I mentioned earlier, needs to match this class name. They need to match. Otherwise, this window that we're creating right now will not be tied to this window class, and none of this stuff will matter. So we need to make sure these names are the same. Uh, so uh, so we could copy and paste this, but that's gonna start getting annoying. So let's see what we can do to make this more let's just copy and paste it. Yeah, we'll just copy and paste it. I'm not sure if it'll like the text. We'll just do this. Copy, paste. Now this should give me an error. Why is it giving me an error? Oh, because this is just a regular string. This is ASCII. We want a long. Windows likes to use Unicode, and it wants long pointer to a constant wide string. This currently is just a regular string, and in order to make it a long pointer, put an L in front of it. Now you have a long pointer to a constant wide string. The next parameter, the window name. This you can give it anything you want. This is going to be the title of your window, the name that goes up on the top here. Up here, if you go into this name up here. So name it anything you want. I'm gonna just name it the engine tutorials. So now we have another style that it wants, right? Actually, I swapped these. This actually goes. MSDN is your friend. If you miss something, extended Windows style. Alright, that's fine. DWord style, Windows style values. Seems like it's the same. So let's just use the same. Look at this. This has overlapped, caption, sys menu, thick frame, minimize, maximize box. And this one just has two. So what does that tell us? That these are actually different, even though they're the same name, same everything, but they are gonna have a different it's gonna do something different. So I'm gonna make this null. This is gonna just default it to whatever and make this WOS overlapped. There we go. Overlapped window. I believe that's what it is. Overlapped window. Overlapped window. Okay. So next we have the X and the Y. This is where on the screen you want to start the program. 0, 0 will tell your operating system to open the window. When you open this window, start the program at this up, top, right, top left corner. I mean that's preference, but there's nifty keywords that will just use whatever. They'll let Windows decide where you want to put it, and it's the CW use default. CW use default. It's just going to use the default that it thinks is best for this. Use D. Not again. Copy. Paste. Alright. Width and height. The width and height of your program. What resolution do you want to run your program at? I find that 1024 by 768 is usually good. My screen resolution 1920 by 1080. Some 800 by 600 might be safer for your computer depending on your native resolution. It wants a parent. Do we have a parent to this window? No, this is our default window. This is actually the parent of any other window it's going to form. So this is going to be null. It doesn't have a parent. Do we have a menu? No. We haven't created a menu yet. The H instance. Lo and behold, now we need access to that H instance again. This H instance right here. Now, if I had made, for all you object-oriented programmers out there, if I had made a get H instance, I would have to call that function again, and it would just cause more issues. So, since I have this global and I've already allocated and initialized it, I can just use that global DH instance, and this is null. So, this will create a window. But as you noticed, however, hwind is not being set equal to it, so we need to set the hwind. This returns, if you can see it, pound define create window ex. It actually returns an hwind. Let's see what, go to definition, create a window, hwind. See, it's going to be returning an hwind. When API, so this is your return type. This is just a modifier, but this is the actual return type. So it's returning an hwind. So we can just set our hwind equal to this. Let's go back to this. So what happens if it fails? Let's say this something's buggy about this. Let's say these don't match, the class name for the window class and the window itself, the names don't match. Well, what it does is something nice. It just returns null. It'll return null if it failed to generate this window, which is good for us because for debugging purposes, I should debug. I hate auto. If debug, if this hwind failed, let's optimize a little more. More than likely it'll succeed. We can do a printf success window class. No, this is not window. Hwind generation. Hwind generation was successful, and we can return true. Else, printf error. Hwind generation was not successful. Return false. This is just giving us an idea of where our code potentially failed. One issue up here, to sidetrack a little, this registered class is in this debug. That's a problem if we're going to be running and release. That means this never actually gets called. So we need a pound else. Otherwise, just if we're not in debug, just register the class. There. Simple fix, but otherwise it would not run and release. So we have this window now, and alright, so we gotta call it from our main. So now if generate hwind, pass in the hwind. Now if this fails, once again return -1. Now I'm not putting any debug information in these ifs because that's just being handled in the actual generation. I'm already handling it down here, so I don't need to do another print or assert to tell me that, hey, I've messed up on one of these functions, because I already did it in the actual functions themselves. So this is what we need to actually. Now we have a Windows class. Now we have a Windows. Now we gotta show it to the actual screen. In order to do that, we're gonna use a function called show window, and it takes in an H1 and the CMD show. Or I guess we could do some show. This is just a pound defined somewhere. Let's check what this. Oh, not F1. Yeah, that didn't show anything. Let's go to definition. 5. Show window commands. 5. Okay, so this is just a 5. So let's see what the. Go here. 5. Huh. 5 is not here. Where's 5? There it is. Activates the window and displays it in its current size and position. So it's just gonna ignore what the operating system is gonna tell us and do its own thing. The default that we want it. Update window. Update the H1. Alright. If I run this right now, let's see what it does. It shouldn't. It might show. I'm not sure. I've never run it right now at this point. Oh, there. Okay. So you got a window showing, and you can see I'm trying to move it. It won't let me move. Can I close it? No, I can't do anything. Oh gosh. I'm stuck. Oh, no, it was just pause. So let's run it again. Showed a window, but it disappeared. I wonder why it disappeared. Well, what we've done is we create our consoles, we generate the window, generate the H-Win, show the window, update the window, and nothing. There's nothing causing the program to consistently run. Well, the naive approach would be just, well, true. Just that's a busy loop, right? And like, let's say if ch, we could do a char ch equals get char, and if ch equals q, let's say. Oh, what is this get? It's not get char. You know what? I'm gonna do char ch, cn, ch. This one's an std. Ch. Alright, now ch equals q, then break. Right, so let's see what that does. Still can't move the window, can't resize it, but okay, it's staying. That's because the console's waiting for an input of Q. And there, well, that's not very useful, so we're not going to do it that way. What we need to create is a message loop. Now this is where the WinProc is going to come in handy, so we're going to create a message to actually update this. This is going to be what's going to be retrieving the messages from our WinProc. We're going to zero it out. Like I said, usually it's good to zero anything out when you can, or when you need to, size of message. So right now this message is empty. There's nothing in it. So So this message has two couple of parameters, but the one we're worried about is this message. And while it does not equal WM quit, I'll go into more detail on that when we get to the window proc. While it's not quitting, we want to do a peak message. Now there's peak message and there is get message. Get message is gonna it's essentially gonna make your program constantly wait to get a message before it does anything. Peak message will, well, here we'll look into each one of these. The peak message is gonna essentially continuously run. So this is going to dispatch the message if any exists. If there's nothing in the message queue, it's still going to run. It's just there's no message in the queue. However, the get message, retrieves a message. The function dispatches incoming send messages until a posted message is available for retrieval. So it's going to wait until it gets a message. So like this sentence says, unlike the get message, the peak message function does not wait for a message to be posted before returning. This is ideal for games because we don't want to wait for the user for an input to run whatever's in our window. We want to continuously run that window. So we're going to do a peak message, and it takes in a couple parameters. It takes in the message, which is essentially this message up here that we're going to be grabbing from the window proc. It takes in an hwin. We can just do null there. You don't really need to worry about that because the window proc is going to worry about the hwin stuff. 0, 0, and this is going to remove the message once it's been handled with. So this is going to actually pop the message queue, the message out of that message queue. I'm not sure the different parameters there, but you want to pop that message out. Otherwise, it's going to just infinitely loop that one message. So we're going to have a translate message. It's going to translate that message. And a dispatch message. Alright, so we got our message queue. This is our message loop. Now you're asking, okay, run it, right? Okay, let's run it. Its behavior's not gonna change. Still can't do. Oh, it's gonna move. Can I resize it? Yeah. Okay, it's resizing. You see this? The little color. Oh, obviously it's not updating, but you got a window and it's moving. Excuse the lag, it's probably the recorder that's causing this to lag up. It shouldn't be lagging on your systems. And we're done. So, okay, so we close out of this. Huh. Why is this still running? Can't close out of it. Why can't I close out of it? Well, we haven't handled any messages in our window proc. So we can close this down. That's done. This is done. So in our window proc, we're just doing default for everything, which is good. But when you just want to do default, but like in this instance, when I close the window, that's a message that I'm sending to the operating system. Hey, close. Sending this is a message. It's a message, actual WM close message. But once I close it, it doesn't do anything. It just closes that one window. And that's the default behavior of just hitting that X at the top right. So we need to actually do something with the window proc. Quickly to mention, we never called this window proc anywhere, did we? In our WinMain, it was never called anywhere. Well, that's because, like I said, this win proc is being handled by the operating system. It is going to be called no matter what you're doing because it's a Windows program. You need to have a win proc in order to do a Windows program. Otherwise, there's no way to interact with the operating system. Maybe in a tutorial down the road, I'll get into more technical details as to why. Um, but for now, just understand that you need a window proc, and the window proc is being called behind the scenes, and it's in this loop. It's going to be called during this loop constantly. Um, all right, so we need to handle a couple messages. We'll do some simple messages to handle some simple messages. Um, so we could use if statements. We're gonna essentially be handling this message. This is a message that's gonna be coming into this window proc, and that's gonna be the message that we have to handle. So we could use an if statements, if else statements, but um, obviously that's not the best branching technique to use here. Um, a switch would be more ideal, and we're gonna switch with this UI message. Alright, so we got a switch set up. We can handle WM create case WM. Got the create. We don't need to do anything with resizing, mouse move. We want to handle the close. This is the axe that we're gonna handle. Let me see if I can get the window proc. Window peak message, window. Is this window style? Window proc. This one. Alright, so I'm trying to find just the list of messages that will be sent. Nope, that's not telling me the messages. Using window procedure. Huh. Alright, I can't seem to find. Let's see, we got WM char, that's alright, so oh, that's just handling keyboard input. I can't seem to find it. So we got WM quit, WM destroy, maybe the message has it. No. Okay. Messages and message queues. Okay, it doesn't. So I'll just I'll just tell you as I go. So we have and case WM destroy. These three we want to deal with more than likely. At least as a default, and at the minimum we want to deal with these. The WM close is hitting that axe. WM destroy is when you actually when the window actually kills itself. Right now, since it wants bodies here. It wants a body here. Just handling some of this stuff. Let's see if that fixed that. So right now, earlier we could click this X and it would do something, and it still does. But between clicking the X and actually the window disappearing is when WM destroy will occur. So it's between hitting the X and the actual destruction of that window. So in our WM create, when we create the window, we could just leave it at the default. because obviously we're creating it. We're gonna be adding more to it eventually to handle joystick input, get handle to input devices and stuff like that, and even setting the console color. We'll worry about the create later. So we can just get rid of it for right now and just let Windows do the default for that. But the WM close, we want to destroy the window. Destroy window. Destroy this H1. Alright, what this is gonna do is it's gonna invoke this message. So now when we get here, we want to get rid of our console and then post quit message. And we can return here. We don't need to deal with the default because we're destroying the window anyway. So this post quit message is gonna essentially post this WM quit, and that's gonna end this while loop. So now when we run it, so we got our window, and it's still resizing. Alright, it's resizing, doing everything we want. Let's close it. And there you go. We got our windows showing, and we have the console disappearing at the same time when we close it. This is one thing I can touch up on quickly since we're here. If I remember correctly. Oops. This is Alright, so this. You see how when I resize it, it's not really doing what we want. This background color, this black, since you can see it now, is actually when we went to the generate window and we created this HBR background brush and set it to null. It's black. Null is 0. 0 is black. So let's fix that quickly. That's not going to take too long to fix. So ooh. Essentially what we want to do so I believe it's in the WM resize. Oh no, size, it's just size. When we resize it, we want to invalidate this rect. We need a rect. And we want to erase. Erase is true, we want to erase it. But we need the rect. So it wants a rect. Okay, so a rectangle. We're just gonna call it the client rect. Get client rect from this H1, and we're gonna put it into the address of this client rect because it's a long pointer rect that it wants. So that'll take care of that. And in here, it wants a pointer to that. So again, it's going to be the address of this client rect. So when we resize it, we're going to invalidate this rect, and that's going to force it to repaint the window each time. So if I run it now, it's still not doing anything. Let's try case WM paint. And this goes in here. No. Surprised it didn't give me that error earlier. seems like I'm missing something. Let's do some research while we're doing this, cause there should validate rect. Anyways, I'll leave that for another day. I'll leave that for the next tutorial. I'll do some research on that. I just don't remember what we need to do for that. So, that's the end of this tutorial. So we have the window. We run it. We have a window showing. We have the debugger showing. Um, yeah. So that's everything. So next tutorial I will work with actually getting into DirectX a little bit and actually getting initializing DirectX, and I'll add some more messages here, and next tutorial I'll just talk about them briefly. But my next tutorial is going to be initializing DirectX and getting DirectX to work with this. So that's the end of the tutorial. I hope you, if you like the tutorial, please subscribe and like my video. This was my first video. If you do need any help, or just if I do more than just Windows programming, so if you need any, if you have some projects that you need help with, feel free to leave a comment, and I'll try to get to them. So yeah, so happy programming. Bye.